Hello guys, we are back with our next tutorial. In this tutorial, let us try to convert the epsilon NFA to DFA. So in this tutorial, let us go through the steps guys, and in the next tutorial, we'll be going through a problem because this problem is really lengthy problem. So if there is a 10 marks question directly, you can expect this question guys. Basically this is really easy, it's not so tough guys. Basically few problems will be really tough, but this is a bit easy when we compare with others. Okay, so basically epsilon NFA to DFA. So what is epsilon NFA? An NFA with epsilon, right? So Q into epsilon union sigma is equals to 2Q. So even here also you will be having the multiple options, right? Whereas DFA will be having Q into sigma, that is Q. Fine, simple. So basically we are having 3 steps guys. So for every conversion we will be having 3 to 4 steps, but it's a loop. If a new state occurs, repeat the previous step, repeat like that. It's a loop. So that's the reason why the problem will become a bit lengthy when compared to the algorithm. Okay, so step 1. So initially we'll be starting as if in the NFA to DFA we have started with the initial symbol. Here also we'll be taking the initial symbol, but remember that I have told you the concept of epsilon closure, right? I hope everyone remember that. Okay, so if you want, I'll be just taking a small example. So it is written really roughly guys. Okay, I'll be just drawing a simple example for you again. Q1, Q2, Q3. Okay, so if it is having something like this, epsilon. So here epsilon closure of Q1 is nothing but from Q1 where you can go without giving any input. So you can stay in Q1. If you don't give input, you can stay in Q1. If you give no input, you can travel. Here it is epsilon, so you can travel to Q2 and you can travel to Q3. So if there is again Q4 and you are not having connection, so here Q4 will not be coming. So only the connections with epsilon and itself are the epsilon closure. Remember it guys, because it's really important in this problem. So if a Q node is the start state of NFA, then epsilon closure of Q node is the start state of DNF. So here let us assume this is our start state. So now I got Q1, Q2, Q3, right? So we'll be giving this whole new name. Let us assume I gave A. So now A will be my start symbol, right? Okay. So now compute the transition of a DFA. Let Q1, Q2, Q3. So this is what we got from here. So for that you will be computing and you'll be getting some points like A, B, C, D, like some points you'll be getting. So you'll be comparing them and you'll be giving the letter. So in this way you'll be continuing until you get the same new state. So if you get a new state, you'll be continuing. If you get the previous states only, you'll be stopping it. Fine. Okay. So let us assume a small example. So I'll be just showing the example here. Or shall I explain you? Okay, I'll be explaining you the method in the next tutorial. We'll be solving it step by step, guys. Okay. So convert epsilon NFA to DFA. That's the question given. So this is the question, guys. Basically, this question will be for 10 marks, guys. I'm giving you a surety that you can just score 10 marks if you are good at this problem. Q0, Q1, Q2, Q3, Q4, Q5, Q6, Q7, Q8 and Q9. Okay, the diagram has just extended a bit, guys. If I drawn it a bit to the left, it would be better. Fine. Okay, so initially I told you, you'll be assuming the start state. So we assumed Q node as our start state. Okay, just give me a second, guys. Okay, so initially we'll be taking the initial state, that is Q naught. So I told you we'll be finding the epsilon closure for that. So we got Q naught. So from Q naught there is no epsilon transition. So luckily we got Q naught. So we'll be assuming Q naught as our A. Fine. So now from state A, what is state A? It is nothing but Q naught. So from state Q naught, we will be traveling with the input A. So from state Q naught, with input A, you can go to Q1. So Q naught on A is equals to Q1. So epsilon closure. Now we will be applying epsilon closure for this result. Epsilon closure of Q1. Luckily, again there is no transition. So now this will become B. Similarly, from input A, we'll be traveling to B. Okay. So is there any transition Q naught with B as an input? No. So we'll be getting 5. So epsilon closure of 5 is nothing but empty. Fine. Okay. So now the thing that is newly added. So if you draw the table, this will be the current status. For A we got B and 5. So what is the new symbol that is added? That is nothing but B. Okay, so now the same process continues for B. Epsilon for B, input A, epsilon closure of what is B? B is nothing but Q1. So for Q1 we got Q1 only. So Q1 comma A is equals to 5. For B we'll be doing B. So after you got a result, so observe here. So till now we got the normal states, but here we got Q1 of B is equals to Q2. So basically we need to apply epsilon, right? So epsilon closure of Q2. So if you observe Q2, Q2 can go to Q3. From Q3 we can go to Q4 or Q6, or we can directly jump to Q8, right? So these are all the possibilities. So we'll be writing all those possibilities: Q2, Q3, Q4, Q6. So that will be a C. So in this way you will be continuing the whole problem, guys. Now from C, AB, now you got D. From D, AB, now you got E. From E, AB. So at the end you will be getting a simple diagram like this. So I think the diagram is really simple to see, right? So but this solution takes around 5 to 10 minutes, guys. If you are really fast and good, you can do it in 10 to 5 minutes, or else it will be taking a bit long also. Here we got D and E. Okay, so here again we got E, and at the end we got the same symbols. So this is the conversion of epsilon NFA to DFA. So in the next tutorial we'll be solving this problem. Don't worry, guys, I'll be solving this with you. Okay, so don't worry. So let us meet in the next tutorial. Thank you. Thanks for watching. Hey.